I will be talking conference outside Japan for the first time after COVID-19. So I'm happy to presenting my talk in Euruko. So today's topic is how resolve gem dependencies in your code. So it's a self-introduction. So my name is HIROSHI SHIBATA. So please call me Hiroshi. So I proudly work as an open source software developer at Andbot. So I'm member of Ruby core team and RubyGems and the bundler team. So I work on maintaining the Ruby ecosystem and infrastructure every day. So thank you for using Ruby and RubyGems and the bundler. Thank you for using that. Oh, okay. So let me introduce you to my company named Andbot. So Andbot provides a SaaS product that is a platform for the construction industry. So our service is built with Ruby and Rails and Golang and TypeScript. So Andbot is one of the supporter for Ruby ecosystem. So because Andbot is hiring me as an open source developer. So I've journeyed over the 18 hours from Japan to be present at Euruko today. So Japan is here, and I'm going to Alaska and over the North Point and Helsinki and return Everest. So Japan is the birthplace of Ruby language. So I'm happy to attend Euruko and Lithuania. So I need to introduce Ruby Kaigi. Ruby Kaigi is one of the large conferences for Ruby language. So we can meet Matt, and many of Ruby core team in this place, me and Aaron Patterson and Kokubun-san and other people. So you can see over the 1,000 Ruby programmers like this. So you can talk about the Ruby language and eat a delicious food and drink. So Ruby Kaigi 2024 is landed in Okinawa, where is a beautiful sea and resort island in Japan. So I'm looking forward to see you again at the Ruby Kaigi at May 2024. Please submit your proposal onto the Ruby Kaigi. Now, let me proceed to introduce the first topic of presentation. So what's dependency resolution with RubyGems and bundler? So first, I will introduce RubyGems and bundler. Okay, I explain what the package manager is. So our package manager serves two primary functions. So firstly, it offers a user-friendly interface. So user interface is an example of installation and upgrades and uninstall and other operations. So secondly, it undertakes the task of resolving dependency among package names and versions. So additionally, a crucial feature it provides is version locking. So this functionality ensures the availability of the consistent list of packages, regardless of the Unix processes. RubyGems is a standard package manager of Ruby languages, So the RubyGems developed under the GitHub organizations. So we have two primary repositories. So one of the RubyGems org is Rails application of hosting Ruby libraries. And RubyGems is a CLI tool for the RubyGems org. While I contribute to both, my main development focus remains on the RubyGems CLI repository. So you can see with me under these repositories every day. Next, I introduce the terminology. So gem is a unit of external libraries, software, or frameworks. And gem specification is a class to define metadata, including gem name, or version, or platform, or the dependencies. Gem spec is a file itself that describes the gem specification. It has two types. So one written by hand for gem releases by you, and the other created at the gem install time. So they are pretty differences. Next, so I introduce the bundler. So RubyGems has a user interface and a dependency resolution, but it doesn't have the ability of version locking. So bundler provides this version locking functionality. So this version lock is achieved by using a gem file, so which you may be familiar with your labeled application. Okay, so next we will look inside of Ruby library and how Ruby loads gems. So you can check the gem spec, which is the metadata of gem, by using the gem loaded specs method with the IRV. So I like IRV. So this is an example of gem spec for rack. So it contains the various metadata. That most important is a dependency section, the second of red frames. So in this example, so rack has 4 dependencies named the Minitest and the plugins or the Minitest, Sprint and global expenses, and the rake. So you can see rack have 4 dependencies, but they are marked with a development. So you can use the rack without other dependencies. So develop dependencies is unnecessary for your application or your code. So it shows the metadata which Ruby gems and bundler use to resolve all the gems and versions required by your application. So Ruby has slightly different gem called default gems. So default gems are gems that can be required regardless of the gem file and can be updated with gem update command of Ruby gems or bundle update command of bundler. So you can check if a gem is a default gem by referring to gem spec. In this example, so you can require RSS library like this, so require RSS, and you can see with gem loaded specs method like this. So gem loaded specs RSS, and you can call the default gem question methods like this. So in this RSS case returns false. So RSS is not a default gem. So in other hand, so OpenSSL case, so this method returns true. So OpenSSL is a default gems. So we learned, so if you want to know our Ruby language, so you should ask our Ruby itself. So Ruby has a bundled gems, so the next one. So bundled gems is automatically installed during installation without the gem install or bundle install. So it's completely the same with your local installation of gems, like Rails or other libraries, like RSpec. So I'm working with organizing default gems and bundled gems on each Ruby releases package every year. Now back to Ruby gems. So Ruby can only require from the load path environment variables. So but So Ruby gems can automatically add the gem path, even if the path does not exist in load path environment variables. So Ruby gems extend the original required method of Ruby. And Ruby gems also inject the default gems passes and other libraries. So your require is slower rather than original Ruby require methods. So it's a typical bit slow. So Bundler has a mechanism to solve this slowdown, which will be introduced later. So Bundler also extends various classes and methods of Ruby gems. So these take effect the moment is Bundler is loaded. So for example, so extension dir methods point to the directory of the C extension library in the gem specification class. So, but Bundler needs to find the Git repositories declared on gem file, like the top of the syntax. So Bundler needs to extend Ruby gems and Ruby original methods. So this section introduces the architecture of Ruby gems and Bundler. Both have a similar functionality and structure. Both have resolver and resolver engine. So Ruby gems uses Molino as a resolver engine, but Bundler uses PubGraph for that. So it's a different implementation between command line interface and the runtime architecture. And command line option and slightly different functionality between Ruby gems and Bundler. So these are completely complex code base. So here are a few new terms. I will introduce them. So the resolution means to make a valid condition based on the combination of multiple libraries. So resolution engine provides a log combination result from the library names and versions, only library names and versions. So finally, the gem resolver. Resolver is a mechanism that abstracts the necessary data for the resolver engine and then provides a gem spec list of libraries to be installed for Ruby gems and Bundler. Oh. Okay. Okay, sorry. So let's understand the Bundler with the Bundler exec command. So how does Bundler lock gem versions and update load paths? So we will use a gem file that only specifies a simple RSS gem. RSS has a library called reXML as a dependency in gem file. So RSS only have one dependency. What happens when you run Bundler exec command? So it will call Bundler setup method. This method only 20 lines like this. So we will investigate these methods. So this Bundler setup method set up Bundler prefix environment variables and modify and related environment variables like path or Ruby opt and Ruby lib and other that. After that, call Bundler setup and full command with a kernel exec command at last. Okay. At first, the Bundler setup verifies the gem file and its log file. If you need to install gems defined by log file, so Bundler will install them. So after that, so Bundler will invoke a clear load path method. So this method rejects unnecessary passes from the load path in your environment variables. When you are using Bundler, only related passes for the Bundler and Ruby gems and Ruby internally are only remained. following the following the removal of the road path, bundler utilized bundler definition to fetch the library collection associated with name and version from the log gem file. In this example, bundler definition returns bundler and reXML and RSS from the gem spec. So next step is setting up environment variables related to bundler again. Lastly, bundler setup will call bundler RubyGems replace entry point methods. So this method replaces the gems defined in the gem file with the default gem introduced earlier by me. So it adds them to specs if the gem file requires a different version than provided by Ruby installation. So after that, this method replaces all of extended RubyGems methods. So bundler will use the original required methods provided by Ruby core. So it's faster than extended methods of RubyGems. So this is the last step of bundler setup. So now we can add passes into our road path via road path variables. So this road path variables is like this if you declared only RSS on gem file. So after that, so bundler update a man path and the log file and return bundler runtime itself. So we can load the latest version of RSS and reXML and the bundler and the bundler exec. So in this time, Ruby only searches these three passes and the Ruby system passes. So because it's faster to load them rather than our RubyGems one. So we learned about the mechanism of bundler, like bundler exec. So in the second topic, we will see how bundler selects the gems we need for our application and updates the necessary versions. Let's look at how works a pub graph. So that is the resolution engine of a bundler. So pub graph is developed by the Next3, so who are original also of a Hammer template engine. So pub graph was originally developed for pub. So it is a Dart package manager. But there are many implementations in other languages like Ruby or Rust or others. So we can see Ruby code here for the internal of PubGraph. So bundler uses PubGraph for their resolver engine since version 2.4. So PubGraph immediately gives up iterating and ignores on dependency tree if it occurs resolution conflict or version conflict. And this conflict information to propagate later processes. So this mechanism allows to run faster rather than Molino, that is a RubyGems resolution engine. So we will look at their details. So let's take a look at how the PubGraph code actually works. So this is a simple example. Gem called at foo and bar defines the above per version dependencies using the PubGraph static package source as methods. So we need to add the gem name and versions combination as a root method like this. After that, we can pass this source definition into instance of a PubGraph version solver class. Finally, we can get the resolution result with calling solve method like this. So this is a very, very simple example. So this time, we simply require bar version 1 or higher, but also depends on foo version 1. So these two versions are selected. So bar 1 and foo 1, and that's fine. So this is the next case. So in the same list of gems as before slide. So, but we need to use the foo version 2 or higher via the root method. So we can see pubgraph will return the pubgraph solver exception like this. So let's inspect in this example. So in this example, so our pubgraph tried to select the foo version 2, but the foo version 2 depends on the bar version 1. So, and the bar version 1 depends on the foo version 1. So the first condition of foo version 2 or higher cannot be valid with the foo version 1. So finally, pubgraph gives up to resolve in this case and will exit with a solve failure exception. So next, third case is a bit more complex. So we have 3 versions of foo and 2 versions of bar and bus. Or we can look the 1, 2, 3, 4, 5, 6 combinations. So if we request our bus version 1 from the pubgraph, so it will look for the bus version 1 and any library versions above version 1 of foo on which bus depends. So I illustrated this. So this is the first try. So there are 2 versions above foo version 2 and version 3. So pubgraph tries to resolve foo version 2 at first. So it depends on bar version 1, and bar version 1 depends on the foo version 1. So it does not resolve foo version 1 specified by bus. So yeah, it's the same case of the second example. So pubgraph will give up in this case. So next step, so pubgraph will look at the foo version 3. So foo version 3 depends higher version of bar version 1. So pubgraph choose bar version 2 finally. So we can get buzz version 1 and foo version 3 and bar version 2. So for the detail of, so it's a bit of complex. So if you need to run the pubgraph algorithm, so please read the original developer blog written by original author of next 3. Okay, so we now understand the basic functionality of pubgraph. So we will now look at how Bundler uses pubgraph to generate a list of gems from the gem file in your code. So the old version of Bundler had a problem with slow install and updates earlier with 2.3. So if you have upgraded Rails version to 7 from 6 or 5 or other older versions, so maybe you have this situation with Bundler update. So this command does not finish as shown here. So let's upgrade the Rails version or enter the key, and Bundler calculates the dependency while 1 or 2 or 3 hours. So it's a infinite loop. So you cannot get the upgrade result. So the reason why Bundler was taking so long when upgrading Rails. So for example, past version of user library called Molino as a resolution engine. Molino can easily do infinite loops with complex dependencies such as Rails and Rails-related libraries in your Rails application. So Rails depends on the Rails type and other Rails component like this. So it's caused by the infinite loops. So I strongly recommend to use Bandra 2.4 or higher. So let's look at the gem file with only two dependencies that are Rails and important map Rails. So Bandra update creates an instance of class called resolver, which uses pubgraph internally. So in the resolver, it invokes setup solver and solve versions methods. Setup solver generates the list of all of available versions of gem retrieved from rubygems.org with your gem file. Their dependencies are extracted and assigned to the variable all specs. It has two virtual libraries, so rubygems and Ruby. So these two are also used for dependencies, handling with Ruby and rubygems versions. So maybe you can see a required Ruby version with your gem spec or other gem specs. So it is handled by these virtual libraries. So finally, resolver have all of versions of Rails and important maps Rails we can inspect in a bundle like this. So all specs and Rails and call the map and extract and internally. So it returns the Rails 0.8 to 7.0.8. And so it contains the all of version of important map Rails and active record, active support, and Nokogiri and other all of gems. So Bandra will slow down in the future. So in solve version, various information created by setup solver is passed to pubgraph, same as my simple example. Self is passed as the source, and this self contains information such as all specs introduced in the previous slide. So, okay, I illustrated them. So it's complex. So Bandra has all of dependency gems declared by all of versions of Rails and important map Rails like this. So it's truly complex for the firma. So after passing the necessary data, pubgraph will run solve and finally create a list of gems and versions that should be installed or updated. However, so if the dependencies cannot be resolved easily, so pubgraph rises pubgraph solve failure from which the bundler will change the dependencies to be resolved and rerun. So for example, so both Rails and important map Rails depends on rail tie gem. In this case, pubgraph is not able to resolve dependencies. We put this conflict information into our names to relax list like this. So I illustrate this situation. So Bandra and pubgraph ignore important map Rails and its dependencies like this. So and pubgraph will propagate in this information with the next try. After that, so solve versions will invoke setup solver again to reset pubgraph's resolver information. So Bandra retry to invoke solve versions again, and we can get the all of list of gems and versions from Bandra. So Bandra will go again and again for the resolving dependencies. So finally, so we can get the full list of Rails and important map Rails dependencies, so like this. So this is an example of only the Rails and important map Rails are only two gems. So in real application in your company, so have over the 50 or 100 gems at a gem file. So Bandra and pubgraph resolve truly complex graph and dependencies. So sorry. So, okay. Now that you have seen how Bandra works, here is what I'm doing now for the future. The big program is that RubyGems and Bandra have many similar command and code base. Okay, sorry. So I would like to make RubyGems uses pubgraph, same as Bandra. And we should maintain one resolver and for the RubyGems and Bandra in the future. So in order to integrate the code base, so I just finished to unify the tools, rake task, and Robocop rules between RubyGems and Bandra in this year. So next is the integration of the code base. At first, command migration between RubyGems and Bandra. So, and after that, so we need to consider a new release strategy for Bandra and RubyGems. So it's a long challenge for me, so as an open source developer. So finally, so I would like to summarize. So I've talked about the knowledge of RubyGems and Bandra and the package manager. So you understood how works Bandra faster with road path modification. Finally, I've introduced a simple example with pubgraph and Bandra. So I appreciate to Andbat for allowing me to spend my time for the Ruby ecosystem and infrastructure. And thank you for attending my talk today. So this is our last message. So Ruby is built to be our programmer's best friend. So it says much. So I will do my best to make a Ruby language that people can consider our friends. So that's all. Thank you for today.